Okay, question 2 then of homework 5 on radians. This is the diagram given with a little bit of extra information. So we were told it was equilateral. The ABC triangle is equilateral, you've been told in the question. That means that all sides are the same length, and of course the side there is a radius of this arc, so I put R there and R there. And then if it's equilateral, then it's split equally down the middle there as well, of course, because that's perpendicular to the top. So that's half R and half R there. Now also, crucially, if it's equilateral, all the angles are 60, so there's 60 there and 60 there. Once we've got those 60 degrees in place, the question about part A suddenly becomes much clearer, because part A is asking for the length of AB, which is what I've called R. Okay, so AB, which equals R. That's what we're trying to find. And so a bit of SOHCAHTOA is helpful here. We've got the angle 60, we've got the opposite side length of 3, and we're looking for the hypotenuse. Okay, so quite simply then, sine of 60 degrees equals opposite of 3 over hypotenuse of R. Okay, quick rearrangement, R equals 3 over sine 60. Bang that in your calculator, 3 over sine, oops, at this stage change my angle input back to degrees. Okay, 3 over sine 60 to root 3. Okay, so I can now add that on, so I'll add that on, that's a 2 root 3 there, and that's a 2 root 3 there. This must then be a half of 2 root 3, which is just root 3, and similarly here, just root 3. Don't know whether we'll need them later on, but we might do, and so that they're ready for us if we do. Right, question B, find in terms of pi the area of the badge. Okay, that is to say the area of the full sector. So sector area, we should now know from question 1, even if we didn't before, it's half r squared theta, where theta is in radians. So that means I'm going to need to put my calculator back into radians, just to be helpful, although yeah, might not be totally necessary. Anyway, so crucially, this angle down here in full is 60 degrees, but 60 degrees in radians is 1/3 pi. We should kind of know that really, but if we didn't know that, and you needed to work it out, remember 60, divide away the degrees of 180, introduce the equivalent number of radians, which is pi radians. So pi radians is 180 degrees, so if you divide away the degrees and times in the radians, then you've effectively multiplied by 1, but in a strange way really, and you've done it in such a way that it cancels the degrees, leaving 1/3 there and pi radians. Okay, so we've got 1/3 pi as our angle. Radius is 2 root 3, so therefore sector area, the half times 2 root 3 squared times 1/3 pi. Okay, and churn all that through, the root 3 squared gives you 3, which cancels with that 3 there to give just 1. 2 squared is 4, cancels that 2 to give 2, so you're left with 2 pi. And that's going to be in centimetres squared. Okay, and then on to the final part of this question, part C. Prove that the perimeter of the badge is 2 root 3 over 3 brackets pi plus 6. Let me just jot that down, 2 root 3 over 3 times pi plus 6. Right, so perimeter then is going to be a radius. Can you see that? So there we are. Radius plus another radius plus arc length L. Okay, so crucially we've already got the 2 radiuses, but crucially we need the arc length L, which is that formula L equals r theta. Theta in rads. Okay, radius is 2 root 3, we know. Angle theta is 1/3 pi, we know. And so that is 2 root 3 over that 3 times pi. Okay, so that's arc length L done there. Overall strategy for perimeter is that arc length L plus the 2 radiuses. So that equals our 2 root 3 over 3 pi for the arc length L, plus 2 lots of our radiuses, which are 2 root 3 each. Okay, and so that then is 2 root 3 over 3 pi plus 4 root 3. Okay, sorry, let me just move that on there. So now what we need to do is get from there to the proof here. Okay, so we need to pull out a factor of 2 root 3 over 3. Just start over here. 2 root 3 over 3. Okay. Okay, pulling out a factor of 2 root 3 over 3. Now that's easy for the first term, not so easy for the second term. Okay, the root 3 has come out, but then 2/3 has come out of 4. So to then sort of figure out what we're then going to have to multiply 2/3 by to get 4, we do 4 divided by 2/3, we get 6, look. Okay, so 6 times by 2/3 gets us 4, so 6 in there times by that 2/3 would get us back to 4. That's why it works. Okay, and that is then the end of question 2.